So you are probably not likely to see the second part here, like the letter C, after 6 hours and then what to do here. Because on your tests, you're probably just going to get A and B. You might get this here. And if you do, like I said, I'll show you what you would get for that. But like I said, I don't think you will get it, but we might as well look at it. So if they give this to you, oh, I put this in the wrong spot. It's fine. It should go here, actually. Let's see if we can bring that up a little bit. There we go. Okay. So this is in relationship to the original heparin protocol question, where you have your 198-pound person, 90 kilograms after conversion. And then it's saying after 6 hours, you check their APTT. You're basically checking to make sure that they're, what their clotting situation is. And you find that you need to rebolus and then you need to increase the rate. And so if you get this question, you'd be using that same data and then assuming that you are starting that your initial infusion was still at 18 units per kilogram per hour. So all you would do is the same thing you did for the first one, is rebolus with 40. So instead of 80, now you're going to do 40. And then instead of multiplying by 18 units per kilogram per hour, you're going to multiply by 20 units per kilogram per hour. So I know you can do this, but I'll just work it out just so you can kind of see 90 kilograms.
Mm-hmm.
Now this time, instead of 80 units, it's 40.
Mm-hmm.
Then depending on if you kind of do it that way or continue on, that should be 3,600, but I'll just double check. Oops. Yeah, 3,600. Units. Then you're going to convert units to milliliters using your bolus dose strength. So that's the 1,000 units per milliliter. And so you'll get 3.6 as your bolus, which is exactly half of the 7.2. And then what's tricky about the second part is knowing what to do with that increase of 2. Your original was 18 units per kilogram per hour, like we have written here. So you're just going to increase it by 2, so it becomes 20 units per kilogram per hour. Which gives you 1,800 units per hour. And then you just convert it to milliliters using your available IV. So that's 25,000 units, 250 ml, which will give you 18 mil per hour. So you were right. One of those reviews had that letter C. I must have moved it at some point, probably because I knew that you're likely not to see that question, but it's still good practice because you're still doing the same stuff. You're just using slightly different numbers in your initial rate. So it's good practice.
Thank you.
You're welcome. Yes. Okay. All right. So all you're doing with this is you're doing two things. You are calculating how much time it's going to take for a particular volume to run out. And then you are then utilizing time to know like what time you would change it. So, and then it does specifically say in this example to use military time. So if we take, yep, exactly right. So divide 500 by 125 and you get 4 hours. Good. And then you checked it at 7:30 and you just take 4 hours from there. Yep, you got it. Sometimes what I think can be tricky, or at least the way they were writing this could be tricky, is where it says 1 liter, but that's where it started. You checked it and it was at 500. So you go off of when it's going to end, not based off of 1 liter. And I think that was potentially a tricky part, but I think they were just trying to give you extra information to see if you could navigate it, including your shift. Again, that doesn't matter either. It just matters when you saw it, where it was, how much time before you need to change it. You got it.